Most students lose marks on implicit differentiation because they forget one small but critical step. In 9709, examiners expect you to differentiate every term, including y, with respect to x. Every time we differentiate a y term, we multiply the differential by dy by dx. So let me take this example. Y squared is equal to, y squared plus 2xy minus x squared is equal to 3. So here, if I differentiate the first term, it's going to be 2y. But because it's a differential, I multiply it by dy by dx. Plus, now the second term is a product of 2x and y. So we apply the product rule here. So the product rule says v u dash plus u v dash. So v is the second term, that's y. And the differential of the first term, that is 2, plus u, which is 2x, and the differential of the second term. So the second term is y, and its differential is 1. But because 1 is the differential of a y term, we also multiply by dy by dx. And then we have minus x squared. So minus x squared, when we differentiate it, becomes negative 2x equals the differential of 3 or any other constant is 0. Now this an implicit differentiation question typically carries 3 to 5 marks, and students will lose 2 marks or more just because they've forgotten this one thing of multiplying a y differential by dy by dx. In this section, I'm going to talk about 4 traps that 9709 paper 3 sets for students. The first error has to do with implicit functions in disguise. Now, typically, an implicit function, a regular function, would look like this. Y is equal to 3x by log x. Now, why is it called a regular function? Because y has been neatly made the subject. There are no y terms on the right-hand side. And this makes it a regular function. Now, what does an implicit function typically look like? X squared minus 4xy minus 2y squared is equal to 1. So our implicit functions in your 9709 paper 3 typically look like this. They are very easy to recognize. So this is what a typical function looks like. Typical implicit function. Now, there are many implicit functions that don't look like this, and students find it a little harder to spot. So I'm going to put some out there. This example was taken from paper 3, an actual past paper. I'm going to put down a few more examples that I've pulled out from your past papers. The first one is like this: log x plus y is equal to x minus 2y. Here we notice that the x and y variables are intermingled. They are not separated into y on one side or x on the other side. They are not even put down in such a way that you can separate them and make y the subject, because you can see that y and x are both inside the log function. So this is an atypical implicit function, and you have to differentiate it as implicit differentiation. So another example would be x squared sine y. You see how a y term and an x term are multiplied, plus cos 3y is equal to 4. This is also an atypical example taken from your past papers. I have a few more here. Sine y is equal to tan x. Once again, it's hard to make y the subject. Cos 3x plus 5 sine y is equal to 3, another implicit function. And finally, x squared log y, intermingled x and y's, plus 2x plus 5y is equal to 11. So in all of these examples, the functions are implicit functions, but a little bit harder to spot because they don't look like our typical implicit functions. So this is what you need to keep an eye out for. Our next error has to do with forgetting to use the chain rule. Now, 9709 loves to test different concepts in a single question. So you might think you're just doing a simple implicit differentiation where you have to remember to multiply by dy by dx, but it could be testing other things as well, such as can you recognize an implicit differentiation, or it might include trigonometry in the question. Product rule is very common, and then there's the chain rule. So this question, I'm going to just write it down. Log x plus y is equal to x minus 2y. Now this question is also a great example of recognizing an implicit differentiation. So you'll notice out here, x's and y's are kind of intermingled. Inside the log function, you have an x and a y. It's hard to separate a y out and make it the subject of the equation. And therefore, it's an implicit differentiation question. You actually get a mark for recognizing that it's implicit differentiation and attempting to differentiate it implicitly. So just attempting to. You don't even have to get that attempt right. So there's a mark for just recognizing it. Okay, so let's say now we've recognized that this is an implicit differentiation. And we need to go about differentiating each term separately. So you'll notice with log x plus y, the x plus y is inside the log function. And typically we know that to differentiate log x with respect to x, when we differentiate it, we get 1 by x. However, this is not log x, it is log of x plus y. And therefore, it is a chain rule question. So, we first just differentiate the log as it is. So, log of x plus y is 1 by x plus y. And then, because we are applying the chain rule, we have to also differentiate x plus y. So the differential of x is 1 and the differential of y is also 1, but because we're differentiating y, we have to multiply by dy by dx. And then on the right hand side, differential of x is 1. Again, differential of minus 2y is minus 2, but multiply by dy by dx. The next two errors have to do with constants in disguise and handling negative signs. So to demonstrate these two errors, I'm using the example x squared y minus ay squared is equal to 4a cubed, where a is a non-zero constant and we are asked to show that dy by dx is equal to 2xy over 2ay minus x squared. So let's start by differentiating each term separately. Now here, the first term is x squared y and it's a product of two functions, x squared and y, and we'll be designating them as u and v. And the product rule of differentiation says that if we're differentiating uv, we get v u dash minus u v dash. So keeping that in mind, the differential of x squared y will be y into the differential of x squared, which is 2x. Sorry, that should be plus. Plus u, which is x squared, into the differential of y, which is 1 dy by dx, because we're differentiating a y term, minus, now we're going to differentiate negative ay squared, so that's negative 2, a is a constant, we leave it as it is, y, and since we are differentiating a y term again, it is dy by dx equal to, and here's where the error again pops in. On the right hand side we have 4a cubed. The tendency is to write 4 into 3 into a squared, but hang on a minute, a is a constant, we treat it like we do any other constant, so the differential of 4a cubed should be just 0. And now we simplify the way we normally do, which is gather all the dy by dx terms on one side and the remaining terms on the other. So x squared dy by dx minus 2ay dy by dx is equal to negative 2xy. Now we factorize, remove dy by dx as a factor, and we have x squared minus 2ay in brackets is equal to negative 2xy. dy by dx would then be negative 2xy over x squared minus 2ay. Now, when we look at what we're supposed to show right there, it says we have to show that dy by dx is positive 2xy over 2ay minus x squared. Ours is looking kind of similar, but not exactly the same. We have to present our answer exactly like theirs. So how do we make this negative sign in front of the 2xy go away? So what you could do, there are several ways of doing it. The simplest way would be to just apply the minus sign to the denominator. So keep 2xy in the numerator and take the minus sign down. So it's minus x squared minus 2ay, and then you apply that negative sign to the whole of the denominator. So 2xy over negative x squared and positive 2ay. And simplifying that and rearranging, we get dy by dx is equal to 2xy over 2ay minus x squared. Let's quickly recap the key mistakes we tend to make in implicit differentiation. The first one is recognizing an implicit function. If the x's and y's are mixed into the equation such that the y cannot be made the subject of the equation, then it's an implicit function and requires that you differentiate it implicitly. When you're differentiating a function implicitly, you want to remember to multiply the y differentials by dy by dx. Thirdly, forgetting the chain rule. If there's a power, a bracket, or something nested, don't forget to apply the chain rule. Fourthly, constants disguised as variables. If it's not y or x, it is a constant. And if it is a term by itself in an equation, then when you differentiate it, its value is 0. And finally, the silent mark killer, losing the negative signs. So many of the mistakes that we make happen after the differentiation is done. So you want to remember to slow down and keep an eye on what your answer is expected to be, which is usually given in the question. And make sure that there are no sign errors in your answer. In 9709, the method is usually straightforward. It's the small slips that cost us marks. So once you practice spotting these errors, you'll avoid the most common traps. I'll see you in the next video.